I think we can already start. So thanks everyone for joining today. I'm very excited about this presentation and talking about two of my favorite topics, GitHub Actions and AWS, which, as the presentation title says, work great together. But quoting Uncle Ben, with great power comes great responsibility. We are trusted by our clients and our companies to automate important processes, to manage infrastructure, things that are critical to our companies. So we should be masters of our tools to keep our processes efficient and secure. So what's on the menu today? We'll start with the usual introductions about who I am, my employer, Automat-it, how to deploy stuff on AWS, well, how to use some effective security practice, which are very simple, but are very important to keep our deployment safe. Then we'll see some more tools we can use to have our applications safe in GitHub, like CodeQL, Dependabot, and GitHub Apps. And then we'll do a couple of demos. The first one is to see a technique to overcome some GitHub limitation about the lack of global timeouts. We cannot set global timeout at organization level. So we'll see how can we use GitHub Apps to overcome this limitation. And then we'll see an exciting demo of a really cool feature of AWS, which are ephemeral CodeBuild runners, is where I want us to spend most of our times, because I think it's the most cool feature that we'll see during this presentation. So the proper introduction. I'm Juan Sanchez. I'm a DevOps engineer. I love learning foreign languages. I love drawing. I love playing any racket-based sports, mostly paddle. I teach and I learn DevOps-related subjects on Udemy, and I work for Automat-it, who made this webinar possible. Be aware that there will be some prizes for the most active members of the webinar. So don't hesitate to participate, to ask questions, or to share your experience with GitHub Actions or AWS, because you might be able to earn some AWS credits. So stay active during the presentation. So let's get to business with our first topics. So very simple topics. I'm pretty sure you might heard about this, or you're already using environments or OIDC Connect. But I think that it's worth at least mentioning them, because they're very important to keep our deployments safe. So first of all, deployments. We automate a lot of things. We publish apps to the App Store. We deploy a static website to S3. We manage our AWS infrastructure with GitHub Actions. So we're giving a lot of trust to this tool. And the things that we do sometimes are sensitive operations, more than your pet project on GitHub. You're managing your company infrastructure in GitHub. So you might want to consider some extra layer of protection. So you can use environments for this. This can allow you to add an additional step of manual validation. For example, you can have someone reviewing the infrastructure that is going to be applied. Or, for example, you want a timer to see the preview of your infrastructure before it is actually applied. You can use protected branches also to restrict some delicate operations to those specific branches and not having infrastructure applied from a feature branch, for example. And you also have some protected variables and secrets if you want to limit the access and the exposition of those. So using them is really simple, as you can see in this workflow file. You simply need to specify the name of the environment, and this job won't start until all the environment protection rules has passed. Notice that there are a variable and a secret defined in this block. So those environment variables and secrets won't be accessible until the protection rules are validated, which is pretty nice. And as I said before, you can define a lot of different protection rules, like the required reviewers, the timer, and you can even build custom rules on top of this. And there are some existing applications that can be integrated as well. Now let's talk about OpenID Connect. When you allow GitHub Actions to interact with AWS on your behalf, you need to configure some sort of mechanism of authentication between the two. And the recommended way is doing it with OIDC Connect, because it allows establishing a trust relationship between both entities without you storing any long-lasting credentials on GitHub. We know this is basic information, but we still see many clients storing AWS access keys on GitHub Actions. So it's worth mentioning that this is the right way of doing it, of exposing your credentials at least as possible, and it will allow you to have more granular control over those permissions and over who can access your infrastructure and modify your infrastructure. Creating an OIDC connection is really simple. You simply need to create an identity provider for GitHub. You will associate a role to it with the permissions that it is allowed. And you can define also a trust relationship, who is allowed to use this entity to assume this role. And we'll see some examples of how can we restrict those entities. With this, you also have IAM Access Advisor to easily track the usage of which permissions and when they were used. And it's an easy way to know which permissions are not used and could be actually dropped to have the minimal permissions for those roles. Inside the workflow, you see it's also very simple. We just have to use the configure AWS credentials action, where we specify a region and a role to assume. And you'll also need to add the ID token permission at the workflow level. Now let's see some examples of how we can restrict the trust relationship in AWS. So first of all, if you want to grant permissions to the whole organization, you can use a trust relationship like this. You can also limit it to a specific repository or to many repositories, a list of them. And then you can go more detailed, more specific to more granular level. You can go to the branch level. If you only want those changes to be applied in a specific branch, you can go there. And even you can get to the environment level. So as you can see, you can really restrict who can use this connection. Now let's go to the next topic. We'll see some other tools to keep our workflows updated and secure. But first of all, let's see an example of a possible risk of using GitHub Actions. And if you work in IT, you're probably aware of SQL injection. Since you're in this talk, I assume you have some basic idea of what SQL injection is. Basically, an attack that consists in inserting some sort of code into our system in an unexpected way that allows that attacker to exploit our system. Like in this example of an angry and I think clever driver, a speed camera, and some image recognition software. I'm not sure if this would work for real, but if the inputs are not sanitized, who knows? If anyone cares to try it, please let me know if it works. So in GitHub Actions, similar attacks can happen. We have user inputs, we have a shell inside our runners. So potentially there could be an expansion of those expressions, and some code could get executed inside our runner, as in this example where we have an issue title from pull request. There is nothing in GitHub that restricts an user from creating a title like this, which is clearly malicious. It has an evil intent. But if that input is incorrectly handled, as it is in this example, it could potentially get executed and do some harm in our workforce. So a tool that can help us with this is CodeQL. It's a tool that's already available in GitHub, and that is really easy to set up. So it can help us spot problems like this. Maybe these problems are not as common and they can be detected with some pull requests, but we're all human, so mistakes can happen. And I really think the advantage of CodeQL is that it's really easy to set up with the basic configuration. Is just one click away. There are many static analysis tools. You have SonarQube, and you have some other security-specific tools that are very smart in detecting problems in our code and not giving too many false positives. But the advantage of this one, I think, is that it's already embedded into GitHub, so it's really easy to set up. When you enable it, you'll have some messages like this, some alerts that will alert you of potential code injections in here, or many other security-related problems and quality-related problems. And what's nice is that you have the context of where is it happening, and also some recommendations of on how this could be solved, like in this example, by using an intermediate environment variable. CodeQL will not be available everywhere. Will be available only where you have enterprise cloud, GitHub Advanced Security, sorry, for private repositories, or if your repository is public. Next, we have our dependencies. Sometimes a lot of the complexity of our applications is hidden inside dependencies, like this portrayed in these images, where we see that all this building is held by this guy, this hero in Nebraska, who has this open source project that is vital for us. So it is critical that we keep that dependency from that guy in Nebraska updated, and all those dependencies in the basement that make our app awesome. We know that it is crucial to have our dependencies updated. There are some security exploits, vulnerabilities, and it's really difficult to stay on top of everything when you have so many projects and so many things going on. So Dependabot can offload a lot of that work for us. And with a simple YAML file, as we DevOps love or hate, I don't know, we can configure how do we want Dependabot to work, which package ecosystems to track, and how to open those automatic pull requests for us. We just have to put that Dependabot YAML file inside our GitHub folder. So one thing I think is important for the usage of Dependabot is to prevent dependency spam. So we'll see some configurations that we can use to minimize the number of PRs that are created by Dependabot. First of all, we define the package ecosystem, the directory of our dependencies file, so our package.json, our POM XML, well, depending on the language, you'll have a different dependencies file. You can specify the open pull request limit. By default, it is 5. If you put 0, you put no limits to it, basically. And we can also specify the schedule for those updates. So maybe we don't want to receive updates all the time, so we can schedule it to happen weekly. But what I think is most important to keep everything clean is to use the groups. You can group the PRs opened by Dependabot. So instead of having one PR per dependency, which is the default behavior, you can group, for example, your minor and patch dependencies into a single group. So I think it's easier to merge your Dependabot pull request when you are able to group them together. Now, let's talk for a bit about the GitHub token before we jump to our first demo. The GitHub token, if you're not familiar with it, it's a secret that is installed, let's say, invisibly by GitHub with a GitHub app on your repository. When you enable GitHub Actions on a repository, it will install a GitHub app behind the scenes. You won't see it, but it is in there. And it will give you some credentials, some tokens to authenticate you to interact with GitHub. The token permissions are limited by default to the repository that contains your workflow. So if you need to access additional resources from outside your repository, you can use some authentication mechanisms, like the one provided by GitHub Apps. And this GitHub app will allow you to access those resources outside your repository. So the permissions at the workflow level, as you have seen, can be controlled with this permissions block. And as you can see in the last step in here, we can use that token to interact with GitHub and make API calls. So the problem with these interactions with other repositories is that sometimes you use credentials that give you more permissions that you need. You'll often see some tutorials on the internet that use personal access tokens, for example. And we'll see what's wrong with using personal access token. Well, they provide no permission granularity. Well, this is improved with fine-grained tokens, but apparently from what I've seen, they don't work with some services. So they might not be a good choice. But still, if you use personal access tokens, they are associated with a user, and the user can change roles, so his permissions can change. That user can leave the company, so you're left without someone having access maybe to some credentials he should not have access to. Many people can access with the same user token, so it's not great for trackability. And you have expiration also, some long-lived personal access tokens which are not renewed enough. So a better alternative to personal access token can be the GitHub apps. You have some scopes for those GitHub apps. You can specify which actions are allowed and on which repositories. And also the credentials generated by the GitHub app will be short-lived, so you don't have to worry if someone were to take those credentials. They could not be exploited for long. So with this, we cover our theory part. So we'll start with our first demo of the global timeouts, or the lack of them. So let me briefly describe what is the problem with this. The problem with the timeouts is that sometimes the jobs misbehave. Let's think of some integration test you have running on your workflow, and you're running on Docker Compose. So you'll spin up some database, for example, and your application, but there is a condition that is never met. So your integration test never managed to actually start. So you end up with a workflow that is running for more time that is needed. So that can end up costing money. You're charged by the minute of the GitHub runners. So we want to be efficient and not be wasteful. So let's see a way that we could use to actually set up timeouts at a global level, let's say, because you can set up some limits inside your workflow at the step and the job level. So if you check the syntax in GitHub, you'll see that there's a timeout in minutes. But if you have, I don't know, 200 repositories, it's not easy to go and change it on every repository. So what we're doing with this custom JavaScript action is to have a failsafe for these timeouts. And you can see in here the default timeouts for the runners are huge. For a job, 6 hours. With self-hosted runners, it's 5 days. And a workflow could even be running for 35 days. So for a job that is not giving any actual value to you, well, it's really a shame to be that wasteful. So the idea with this action is to invoke it periodically with a schedule. You'll need to create a GitHub application. That's why I was talking about that just before, so you have that information fresh on your mind. And you'll specify a timeout in minutes. Here, it's just set to 1 for the purpose of the example. If you use it for real, you might want to set it up to, I don't know, 3 hours or a reasonable time, so you stop jobs that are misbehaving already. And in this step, we'll simply print a summary of what has been stopped by this workflow cleaner. So let's look a little bit at the code, just briefly, just to show you what's being done. Here we have an index that we'll just call this main run action. In here, we'll extract the actual information that is needed to perform the cleanup and kill all those rogue workflows. So the GitHub private key and the app ID. And then we'll call our workflow killer and write a report. So if we see what's happening in the workflow killer, let me see, where is it? So here we are iterating through all the app installations and through all the, through all the repositories and through all the workflows that are currently running. We'll limit the scan rate to some days, not to bring many workflows as candidates. And then if they are compliant with our timeout condition, they are simply stopped, and the reported will write a summary as a markdown. So for this example, let's just open a couple of repositories. So we have in here timeout action user 2 and timeout user 1. We have a couple of workflows. One that is sleeping for 5 minutes. It's the workflow we want to kill. And then we have the workflow killer, the call to the workflow killer, where we're killing the jobs. So let's run the actual timer. So this will be running for 5 minutes as defaults. And let's run it in here as well. We'll give it a bit of time for it to run. And we can see that we have our GitHub app installed in here. It has only permissions over these 2 repositories, and it has these 2 permissions. We need to read and write to access to be able to actually stop the jobs. So they have been running for some time now. Now we'll invoke the workflow cleaner. this would usually be done by a scheduled workflow, but here for the demo, we'll just running it directly, and we'll see if it is capable of detecting if these jobs have been running for more than a minute now. Maybe I have invoked it too fast. Let's see. So right now there's nothing that has been running for more than a minute. So let's run it again. Now, 1 minute ago, now it should be good. It should detect that it has some work to do. And there we have it. We have 2 repositories where it has detected that there were workflows running for more than the specified time. So give us some information, how much time they had been running for, and whether it actually managed to stop it. Since it does it with the HTTP call, maybe it failed. So there we have it. Okay, I don't know if you have any questions about this, or maybe we can wait. We can do the CodeBuild demo if you want, and then we'll start with the questions. I want to be sure that you can all see the CodeBuild part, which I think it will be the most interesting. So let's switch to our second demo right now. Here on my, let's move this here, on my AWS sandbox account on CodeBuild. So I'm going to show you how to configure this in the easiest way. There are many possible scenarios. So I'll try to talk a little bit about them while I configure it, but I'll explain like the fastest way so we can see how it works. So first of all, we're going to create a build project, and we'll assign a memorable name in here. I'm going to call this project runners. You'll see that this project name will be used in GitHub. We'll see how afterwards. Now, as a source provider, of course, I'm going to choose GitHub. It will tell me that I am not yet connected to GitHub. So we can click here and manage default source credential. And we have 3 ways of configuring it. As I said, I'm going to do it in the fastest way with the Auth app, but you can also do it with GitHub app or personal access token. So this will create a new secret to handle that connection with GitHub, and that secret will be stored on Secrets Manager. At least that's the recommended way of doing it. Now this triggers the OAuth workflow where we see the permissions that AWS needs for interacting with GitHub. It will create a webhook on our repository or our organization, depending on how we do the setup. So we're going to authorize this application, and now I'm going to give a name. Is the name that's going to be used for Secrets Manager, and we'll save it. And if everything went correctly, we should see well, our secret in here. You'll see that I also have a secret for CodeBuild. We'll use that later as well. And I'm going to do this setup for a single repository. You could do it at the organization level as well, but we're doing the simplest setup for the demo. If you were to use a GitHub application, for example, in here you would already have a predefined list of the repositories where you have given that GitHub application access to your code. In here, we're defining a webhook, and we're specifying an event. So we're choosing the workflow job queued. That means that when a job is queued on GitHub Actions, it will trigger our runners in CodeBuild. I won't bother much about the actual environment because we'll see that we are able to override the environment from the workflow itself. So I won't care about these configurations for now. Just be aware also that you can create automatically when using the console a role that's going to be used by CodeBuild. We'll see a bit later which permissions are set. And I will leave the rest of the defaults. So if I create the project now and everything is okay until now, we should see a message saying that the project was created correctly. You see it in here. If you have some problems with permissions, you will see in here like a red banner, and you'll have some clues about the error. So let's see the permissions in this role. So as you can see, there are some permissions for logs, CodeBuild, and in here, permissions to access the secret that we created before during this creation of the OAuth connection. You'll also see at your repository under integrations, GitHub Apps, for your global applications in here, you have the authorized OAuth app in CodeBuild. If you're using a GitHub app, you'll see it in here. So just be aware that that will be created at your profile or your organization, depending on how you do the setup. And now let's head to the webhooks. When you finish the setup, a way to see if the connection worked also is to go to your webhooks, and you'll see that a webhook was created, and there's also a ping that is sent. So you'll have a green check marking here that will inform you that the connection is working properly. Yeah, I think I have not forgotten anything about the setup. Let's see the first workflow we have in here. So in here we have a workflow where we specify runs on, as usual, where we'll use the CodeBuild label, and then we'll specify the label from our project, our CodeBuild project. That is how GitHub knows that this workflow needs to be run on our CodeBuild runners. We'll also specify some information about the run ID and the run attempt that we take from the GitHub context. And in here, I'm just printing some environment variables from AWS or CodeBuild, and I'm printing some system information to know on which type of runner I'm running. So if we run this action, we should see that after a while, it should trigger a build in here in CodeBuild. We see it in here. I have seen that the time can fluctuate a lot. Sometimes it's very fast. Sometimes it can take a bit more of time, but it's usually quite fast. I mean, very reasonable. Take like 1 minute to start. We'll give it some seconds since to start, and then it needs to bootstrap the runner. And now it has run, and we see some information that we're running inside AWS, and that we're running on this kind of machine. So now that we have seen a first run, let's talk about a couple of things why it would be interesting running with GitHub CodeBuild runners. Why I think this is so cool. First of all, because it's really easy to run this type of runners inside your VPC. Sometimes that is required by regulatory reasons. Also, you can use the secrets manager integration. So instead of using the secrets inside your GitHub account, you can have it more tightly secure on AWS. So those are a couple of advantages. You don't need to take care of patching those runners. If you were to run some long-lasting runners, for example, you would need to patch them. So you can offload that to AWS. You have CloudTrail integration, and the price is cheaper than the GitHub runners for most scenarios. I tried to do price comparison. So let me show you what I did. So I used the prices as they are specified on GitHub and on AWS, the price per minute. I didn't take all the types of runners there are, but I took some of them, and I didn't take into consideration any additional factors like storage or data transfer. Okay, so you might want to take those into consideration if you plan to use CodeBuild runners. But I think it's usually also cheaper if you take into account data transfer. Let's say, for example, that you need to pull images from a private registry. So you can keep your traffic private. If you use that runner inside your VPC, you could keep that traffic private. So I think all in all, you would save from that part as well. So I took this per minute cost, and I calculated how much it would cost for 2,000 minutes, 3,000 minutes, and so on. This is per month. And I took out the free tier. So for GitHub, you have 2,000 free minutes, and for CodeBuild, you have 100 free minutes. That's why with 2,000, it's free for small runners in GitHub. So if you then plot all this information, you'll see how let's see what size I'm plotting here. So I'm plotting for an Intel type of machine and 2-core. So you'll see that AWS starts to be cheaper. So the lower the the line, the cheaper it is. So starting from 6,000 minutes, AWS starts to be cheaper. If we change to Intel, it changes a little bit, but you see that from 3,000 minutes, AWS it's cheaper. And with bigger machines, like, I don't know, 4-core, for example, AWS is cheaper than the GitHub runners, just because you don't have a free tier with large runners in GitHub. Well, I could show you more data from this, but the idea is almost the same. If you use more minutes, AWS will be cheaper. Let's see now a second example of what I mentioned before using the secrets manager. So let me show you the code first. So here I have secrets. So this is an environment variable that will be injected by CodeBuild. If we define it in here for a project. So let's edit our project, and now we will change the environment. So here in visual configuration, I'm gonna inject an variable name. And from secret manager, I'll just take this value. This is nothing very secret, as you'll see, just my super secrets. And I'll specify the value in here and specify that this comes from secret manager. I'll update the project. And now I'm refreshing the permissions in here. If you remember, we had only 2 policies before. And now, since I allowed CodeBuild to modify these permissions on my behalf, we'll see an extra policy to retrieve secrets from secrets manager with this prefix, CodeBuild. I think this is by default. It's not because it detected that I used this prefix. So be aware that you'll need to modify your policies if you have secrets that are not under this CodeBuild prefix. So if we run this workflow now, we'll see that we're going to be able to retrieve that secret from secret manager and read it, which is pretty nice if you want to keep your secrets tight inside AWS and don't expose them to GitHub. So let's see if it starts quickly. You can see in here, there are some tests, and you'll see that it usually took like 40 seconds, but there were some that took a little bit more. So time fluctuates. If you want to check exactly how much time it takes, you can go to your build history, and inside a run, you can see the phase details, and you can see where it takes most of the time. I mean, if time's critical for your runs, you might want to measure them well, average the time it takes to run. Well, here we'll see that now we could read that secret from Secrets Manager, but it has not been masked. This is because GitHub is not aware that this value is a secret. So you need to do some manual steps to actually mask those secrets. So you can do something like this. If you want to tell, hey, GitHub, this is a secret, you need to be aware of it. To mask it on the log, you need to use this function along with your secret. And then I'm not going to run this one. I'll just show you that it is capable of actually masking that secret. It won't print it to logs again. Let's see another feature you can use. and it's the possibility of overriding your environment. As I told you before, when I configured the project, I was not taking care of which environment we were going to use because you can easily define that on the workflow. I think this makes a lot of sense because in each workflow, you know what kind of compute you need usually. So you can, besides adding the label we added before, you can specify an image and an instance size. So here we're, in fact, I'm gonna run it and then I'm gonna keep on explaining. So CodeBuild runners, run. So as you can see here, we're using this matrix strategy to run on 4 different types of machines of 2 different architectures and sizes. And we're just printing the information of the system name and the number of processors. You have the full syntax in the documentation. So you have these label overrides for what I've mentioned before, also the build spec override, or if you want to use a fleet, you can have provisioned capacity in CodeBuild. I haven't played a lot with it. That's why I'm not talking about it during the demo. But you can use fleets as well with this. If you want some provision capacity, I think it could help with the startup time, but I haven't measured it enough to actually assure you that it is as fast as GitHub runners. So if we check right now our logs, we'll see that 4 jobs were run on 2 different compute environments. So here we have Amazon Linux version 5 in a medium size. So information about the processors and the system. Well, here Amazon Linux 2, small, so only 2 processors, and so on for ARM and the different 2 sizes. Okay, we're almost getting to the end. So as you might know, there's like this relatively new feature of running CodeBuild on Lambda runtimes. So you can also use, for example, a Lambda Python environment or a Java Lambda environment. And here we're using these 2 environments. You have some limitations, some because of Lambda, for example, the 15 minutes limit, and well, you cannot build Docker images with it, but this might be a cost-effective option for some short scripts, maybe that run faster than 15 minutes. So just so you know, you can also use Lambda in here. So let's run this one. And well, maybe just give it, let's just give it some seconds for it to start. These environments should be pretty fast to start usually. So let's see. Well, I didn't speak much about what's being done in the code, but it's just, we're just printing the Python version and we're running some greeting on Python. And for Java is just the same. It's we print the version, we compile, and we do a hello world. So as you can see in here, we use the Lambda execution environment where there's a Python version, and we run our short, very short script. And same for Java. So last, some gotchas. we have seen with it is the setup of languages. In here, we have, for example, a Python version that comes along with the runner, but we try to use the usual action from GitHub Actions, and we'll see that it doesn't work as intended in here, but it actually works on some other runner in Ubuntu. So let's run this one. This is just to tell you that if you're using these kind of actions, they might only be prepared for some runtimes. A colleague of mine told me also that he had problems with PHP, so he had to do like this workaround for changing the path. Nothing too complicated. But be aware that you might need to check carefully if there are any conflicts between the runner and the setup of these language actions. So we'll see in here after a bit that this will work for a runner in Ubuntu, but it will not work for this other runner running on Amazon Linux too. I think that's about it for the demo. So maybe let's start with the questions. OpenID versus setting direct AWS keys. Yes, if that's the case, then I think the biggest advantage is that the credentials are are short-lived. So if those credentials were lost, those AWS keys, then they could exploit your infrastructure. And with OpenID Connect, as we saw before, we can restrict which entities have access to change our infrastructure, to make changes. So that would be limited to the usage of our repository or our organization, whatever we define on the trust relationship. Okay, the next question. How to print out summary like in example with Cleaner. Okay, so there's an example in the actual action. Let me try to show it. So in here, this cleaner will produce an output. So you take the ID from this step and you get the report output. And you send that to the GitHub step summary. So in that way, you can print that that summary. Okay, will CloudTrade correctly track GitHub user for every single round, or there will be some OAuth username for everybody? I don't know which CloudTrade are we speaking about in here, because if we're talking about CodeBuild, I think you will only have the role that is assumed by CodeBuild. So I don't know if I'm answering the question actually. But in fact, I haven't checked for the details on on CloudTrail, so I cannot really tell for sure. Um, I can try to check out later. Have you compared with Kubernetes runners? Any pros and cons? Well, I have used Kubernetes runners, so I think what's good about those is that if you already are using Kubernetes and you're comfortable with it, you maybe have some instance reservations, so it could be uh, price effective. Um, if we talk about time for startup, I cannot tell. I have not compared both of them, but I think if you already have that kind of setup, I mean, Kubernetes is really dynamic, and you're already running inside the VPC probably. So I would say the biggest advantage is in there is the integration with secrets manager maybe. But I think the key factor in there might be speed. How long does it take to provision your runners inside Kubernetes? Okay, what was added to the secrets manager? Token to access GitHub Actions. As understood, GitHub app has a best practice is to integrate. Yes, you could set it up as GitHub app. I didn't do it during the demo because it takes a bit more time. You need to specify some trust relationship, sorry, some permissions in the role. But yes, we did an OAuth workflow. So I think a token was stored on the secret manager. But you can do it with a GitHub app. So the setup is not really that more difficult. You just need to provide some extra permissions for your role. According to documentation, blah, 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 there's no way to fetch repos from AWS internally. So I understand that your use case is that you want to fetch from one workflow another uh, repository, clone other repository. So that you would need to go to the internet. There's no way to fetch repos. I think I think it is true because this private link is something that was set up for GitHub Enterprise. But thinking it without actually knowing, I would say that it's not possible. What alternatives to CodeQL, for example, for private repositories, do you use most often in your practice? I have mostly used SonarQube. So SonarQube used to be more code quality oriented, but they had made a lot of improvements on the security aspect side. It was not their core business, but latest SonarQube versions have some nice security features. They do taint analysis, so they know the abstract language tree of they understand the code, so they know which paths can lead from an insecure input, for example, to a potential vulnerability. So they do this taint analysis. So this helps not having so many false positives, and you have these workflows for marking security issues as false positives. So it's quite nice. I don't know many other tools by name right now. There isn't anyone that comes to my mind. There are some that analyze dependencies, for example. I think you have some in GitHub. You have secret scanning as well. So those are available. But yeah, if we're talking only for private repositories and you don't have a paid account, maybe SonarQube is one of the most popular. And you have the SaaS, you have Sonar Cloud as well that can help you with that. Um, so what is the best strategy to combine GitHub free tier and CodeBuild? Um, that's a good question because I don't know how would you actually switch it dynamically, but what would be cool would be to use the uh, first 3 minutes, 3,000 minutes, set up an alarm, a billing alarm, and when you get there, you start using the CodeBuild runners. But I don't know how could you switch dynamically those labels. Maybe if you could switch the labels dynamically, it would be a good strategy. But I haven't actually played with that. But if you're using large runners, for example, I would recommend start from the beginning with CodeBuild runners. If the setup of the runner, the runtime, the time it takes to start the run is not critical for you because as you can see in here, with large runners, AWS is cheaper from the start. So I would definitely study that possibility directly if you're using larger runners, sorry. What if this is used with AWS AKS, where Argo workflow will be installed? Da, 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 da. I don't know if I get the point of your question. What's the concern in here? You're running Argo from the runner, I would assume, but I don't see what would be the issue with it. Maybe if you can add some details, I would appreciate it. What are the limitations for GitHub apps? What is the best scenario which would justify developing a custom GitHub app? Well, for me, there's like a difference in here between developing a GitHub action and developing a GitHub application. So the GitHub app is just like a way of giving some entity credentials and permissions to act on your behalf. So the idea would be to use GitHub apps when you need to interact with many repositories. So that would be a use case for them. And when to develop a GitHub action, well, if you have some repetitive task that you do on many repositories, that could be a good opportunity to build a custom GitHub action. If I didn't answer your question, Lucian, please let me know. Is it possible to use Spot instances separately, set up via EC2 Scala Cube or CodeBuild instances only? I don't know any way of using Spot instances. From what I've seen, you can use fleet. You have these compute fleets, but when you create a fleet, you have like this capacity compute. Uh, VPC, but I don't see any options to configure spot instances for these fleets. And in the project, I don't think there is any option either. I wouldn't be as categorical as to say it's not possible, but I don't know any way of doing it, at least. We see here in under environment, I don't see that it is there is an option to tell them to specify to use spot instances. So my instinct would be saying no. Maybe it is. So if anyone knows it, please let us know. Uh, is it possible to use HashiCorp Vault to work with secrets in this approach? I don't know. I cannot really tell. I have never worked with Vault and GitHub Actions. I imagine there would be a way, but I don't actually know it. So if anyone knows it, feel free to answer. Will this presentation be published somewhere in the end? Alexei, I don't know if we have a way of sharing it. I guess
Yeah, we
we
can
could.
just upload it to Google Drive and share.
Okay, then let's do it. If using a non-administrative AWS key as a secret in GitHub Actions, still consider vulnerable. I mean, everything is relative. You could have this associated with some permissions which are not insecure, but I think OpenID Connect is the recommended way because the credentials are short-lived and limited to the repository. So I see many advantages of using OpenID Connect. And as we've seen in the presentation, it's really easy to set up. So would it stop workflow if job waits for runner? Maybe I think we're talking about the custom action for stopping the workflows. I would need to recheck the code, but I think we filter by status, and I only grab one single state. Let me see if I can find it quickly enough. So workflow killer in here. So we have these stoppable states. And where were they? I don't remember where I defined those. But probably I would say no. If it's waiting, I will just wait for in progress. In any case, one of my plans was to make this customizable. So it could be an enhancement, but right now there's only one state that we look for when we search for candidates. Can we use custom AMIs with already pre-pulled Docker images? I think at least you could define it for the default environment. I haven't actually tested using custom AMIs, but to be checked. I think for the default environment, at least it should be possible. Kindly share the Excel. Okay, I can share that. Any any feedback on the Excel would be welcome as well. All of the costing are for Mac or Linux or Windows OS. I only considered for the Excel Linux machines. Can you comment on the runner image? Are they same or different versus GitHub runners? I think there are differences, as you have seen when we try to set up for example, the Python environment. So you will definitely see some differences. So don't expect them to always act just the same under all the circumstances. Can you store images for GitHub runners in ECR? I guess we're talking about maybe pre-built images for CodeBuild. I think you can in general, but I don't know if there are some limitations for the GitHub Actions runners. Spot instances, so same thing. I think not. I cannot assure you that you can't, but to my understanding, you can note. Code star connections to enable to group repos but simplify the connectivity with CodePal. You set up the auth, but worth showing the underlying connections established. Yeah, you might show that. I guess you're talking about this part in here. So the connections. When you define, you can create a connection in here for GitHub. You give it a name, and here you can authorize the connector. And here you have also the app installation if you want to use that authentication method. So you'll see them in here. And just a little gotcha, these connections are region specific, so be aware of that if you need to, for example, set up some permissions. I guess you were talking about that, Darrell Cox. I'm not 100% sure. Can we somehow to influence the software that is configured with the runner? For example, if I need Docker, how can I pre-install it within a new runner? You will already have Docker pre-installed in the runner. I think if you're able to create custom images, you could do it that way. I'm not sure if you can use them along with the runner for GitHub Actions, so it would need to be checked. And you can always add a step on your workflow to install some software, but well, maybe it can be can add some penalties time-wise. So I think the good way would be to create your own AMI Docker images or Docker images. So maybe that's the way to go, but I haven't played with that. So in case of a project that weighs approximately 1 GB, which pull or clone method does CodeBuild use, and does it support large project? Are there any nuances or recommendation for using CodeBuild in case of GPU builds? In the case of I don't get what is the deal with this one. I guess you're worried about a heavy project, but I really don't know. I haven't studied downloading large bases, so I don't know if you would find any issues in there. About GPUs, I think you have some GPU machines available. You can check the available runtimes in there, so in the label overrides. And there are some GPU, where was it? Supported. So these are the compute images supported. So you have some GPUs in there. So you can see what's available in there. GPU, you have some of them for some runtimes. And I don't see any clues in the documentation as to how to use custom environments. So cannot really answer that question either. So I think That's it for the presentation. Thank you very much to everyone that has assisted and that is still alive after 1 hour and a half. I hope it was interesting and that I had shown you some new information. And Alexei, a question about the the credits. Have you actually taken down note of everyone posting questions to know which who will receive those credits?
Yeah, I guess we actually have a history of questions and chat. So after some rest, we will analyze it and decide
Okay,
who
I
will
think we
win.
have everyone's emails as well, so we'll get in touch
Yeah.
with you for those credits. And thank you all again for assisting. It was really fun for me doing the research and also presenting it to you. Have a nice end of the day, everyone.